Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over how to rearrange log expressions using the properties that we've learned. So I'm going to go over 4 examples, 2 condensing examples, and 2 expanding examples. So let's just go into example 1. So when I come across a problem like this, I usually look at each term individually and then try to combine them all together. So let's look at this first term, 1/2 log 3x. So this 1/2 on the outside, if we want to condense it, because of property 3, we can put it as the exponent on the inside of the log. So with this first term, if we condense it, it'll turn into log of 3x to the 1/2 power. And now let's see what we can do with the second term. We've got a 2 log 6. So we can put that 2 in the exponent of the 6. So we end up with log of 6 squared. And then the third term, we can't change at all, so we'll just leave it like that, log 2. So now we can combine all the terms together. We're going to do log, and then since we've got these 2 logs added together, we'll multiply their contents. So 3x to the 1/2, which we'll make look simpler soon, times, and then we'll just make 6 squared 36, just for simplicity. And now we have to divide by this log 2 since we're subtracting it. So we'll divide by 2, and now we'll simplify the inside. So 3x to the 1/2 power, 1/2 power really means square root. So we've got log of the square root of 3x times 36 divided by 2. And now we can simplify this 36 divided by 2 thing. So we end up with log of 18 times the square root of 3x. And that's the final answer for this example. So moving into example 2, it's also a condensing problem. So again, just like the last time, we're going to take each term individually, see what we can do, and then combine them. So the first term, we've got 3 log of 2x squared. So this 3 on the outside we can just put onto the inside as the exponent. So we've got log of 2x squared to the 3rd power plus, now this second term, there's not anything really we can do with this one, so we'll just leave it as is, 9x plus 2. And then here we've got log base 5 of 12x, which we're also just going to leave. Now we want to combine the logs that we can. So we've got 2 log base 10s. Remember, if there's no base shown, it's just log base 10. And then we have a log base 5. So with these properties, they don't work if the bases are not the same. So this log base 5 is going to stay the same through the entire problem. But we've got these 2 log base 10s that we can combine. So we can end this, or we can combine these as this 2x squared to the 3rd times 9x plus 2 minus that log base 5 of 12x. So now we want to simplify this inside part. So 2x squared to the 3rd power, remember we have to distribute this 3rd power to both the 2 and the x squared. So we're going to have log of 2 to the 3rd power is 8. X squared to the 3rd power is really x to the 2 times 3 power, which we can rewrite as x to the 6th. I'll write that a little prettier. 8x to the 6th. And this is still times that 9x plus 2 from earlier, minus the log base 5 of 12x. So now we want to simplify this inside even more, so we'll distribute the 8x to the 6th to both the 9x and to the 2. So we end up with log of 72x to the 7th plus 16x to the 6th minus log base 5 of 12x. And since we can't get any further than this, this is our final answer for this example. Now moving on to the expansion examples. This is kind of the same process, but just in reverse. So we want to look for things that we can break apart into multiple pieces. So first off, let's just try to get it into multiple terms, and then we'll simplify those terms. So we've got log of 4x squared times the square root of 5x divided by x squared minus 16. So let's just use properties 1 and 2 to simplify this, or to break this down into 3 terms. So we've got log of 4x squared. Since these two are multiplied to each other right here, we can add a log of the square root of 5x. And then we're dividing by x squared minus 16. So here, let me move this other example over real quick. So since we're dividing by x squared minus 16, we'll subtract the log with that contents. So minus log of x squared minus 16. So now from here, we want to simplify each of these terms to expand it as much as possible. So log of 4x squared, I want to be able to pull something out of this, but looking at it right away, there's not a whole lot that we can do. But if we look at it a little harder, this 4x squared, we can really think of it as 2x, the quantity squared, since that squared goes to both the 2 and the x. So we can pull a 2 out, actually, and we end up with 2 times log of 2x on the inside. Now, log of the square root of 5x, remember the square root is really the 1/2 power, so we've got 5x to the 1/2 on the inside, really, which we can pull the 1/2 out of, and it leaves us with 1/2 log of 5x. And now this third term is where it gets a little tricky. So if we're being a little observant, we've got x squared minus 16, which is actually a difference of squares. So we can factor that into the two pieces, x plus 4 and x minus 4. And now since these two terms are multiplied to each other, we can break that into 2 more logs. So we've got minus the log of x plus 4 plus the log of x minus 4. And since we're subtracting this whole term, we'll have to simplify the addition and subtraction here. So I'll just rewrite these first few terms. So log 2x plus 1/2 log of 5x minus the log of x plus 4 minus the log of x minus 4. And now we can't get any further than this, so this is our final answer. And now finally, example 4. We're going to use the same process that we did for the last problem. I'll move it into a more open space for us. We've got the log of x squared plus 12x plus 36 over the cube root of 20x. So once again, let's just split it into the multiple terms that we can. So we've got the log of the top, x squared plus 12x plus 36, minus the log of the bottom, the cube root of 20x. So now we want to simplify each term separately. So the inside here, it doesn't look like we can simplify it right away, but this is actually a perfect square trinomial. So we can factor this out into x plus 6 squared. So we've got really log of x plus 6 squared minus the cube root of 20x. Just like the square root, we can turn this cube root into a fraction exponent. So we've got really 20x to the 1/3 power. So now each of these exponents we can bring out front, and we get 2 times the log of x plus 6 minus 1/3 times the log of 20x. And this is our final answer. Yeah, so that's about it. All you really want to do is try to keep in mind all three of your properties, and make sure that the log expressions have the same base before you try to combine them. So yeah, that's about it. Thank you for watching.